In the previous video, we learned how to display an image by using imshow function. Let me give you another example. First, I read the image, and then by using imshow, I display the content of the image. So this image type is unsigned integer 8. So the content of this image will be intensity values between 0 to 255, as you can see here. But not all image matrices come so nicely bounded up into this data type. A lot of MATLAB image processing commands produce output matrices which are of type double. Let's see how we can display an image from this type. There are two choices with a matrix of type double. You can convert it to the type unsigned integer and then display it, or display the matrix directly. The second option is only possible when the values of the matrix is between 0 and 1. So let me show you. Assume that I convert the image to the double type by using double function. As you can see, the CD variable is exactly the same size of the I variable, but the type of the value is double. If you check the content, you will see that these values are not restricted between 0 and 1. So if I display this figure, all of the value greater than 1 will be converted to the white. So if I display CD, you can see everything is white because all of the value are greater than 1. So in order to fix this problem, you should scale the content of the variable. You can do it by divided by the 255. So if I divide it here, you can see the double image is displayed on the screen. Or if I change it in the workspace also, and then show you the content of this variable, you can see all of the values are between 0 and 1. 0 for black, 1 for white, and the other values between 0 and 1 will be multiplied by 255, and then it will convert to the integer by the floor function, and that value will be displayed as the intensity value of that pixel. Another way to convert the image from the unsigned integer into the double format is using a built-in function from the image processing toolbox. I name it CD2 image to double is the name of the function, and I will give it the unsigned integer variable I. Don't forget to put semicolon in the end of each command. Now if you check the CD2, you will see that it is automatically bounded between 0 and 1. So figure this is the double version. Let's see how we can convert an image into the binary image and display it. As you remember, a binary image will have only two values, 0 and 1, but MATLAB does not have a binary data type, but it does have a logical flag where unsigned integer values as 0 and 1 can be interpreted as logical data. The logical flag will be set by the use of relational operations such as equal sign, less than or greater, or any other operation which provide a yes or no answer. For example, let's see what will be the output of this command. As you can see, the variable i2 is the same size as the original image, but the type of the data is logical. For each pixel of the eye, this condition will be checked. If its value is greater than 128, it will be 1, otherwise it will be 0. So as you can see, for these pixels this is 1, for some of them it is 0. So in fact we convert the input image into the binary image. Let me display it. So this is the binary image and this is the original image. By the constraint I greater than 128, I change the intensity into the black or white. Grayscale images can be transformed into a sequence of binary images by breaking them up into their bit planes. If we consider the gray value of each pixel of an 8-bit image as an 8-bit binary word, then the 0-bit plane consists of the last bit of each gray value. Since the bit has the least effect in terms of the magnitude of the value, it is called the least significant bit, and the plane consisting of those bits is the least significant bit plane. Similarly, the 7th bit plane consists of the first bit in each value, and this bit has the greatest effect in terms of the magnitude of the value. It is corresponding to 128. So it is called the most significant bit, and the plane consisting of these bits is the most significant bit plane. Let's see how we can display these different planes. First, I have to convert my image into double. Now we can isolate the bit planes by simply dividing the matrix CD by successive power of 2. 2, 4, 8, 16, 32, 64 and 128, and throwing away the remainder part and seeing if the final bit is 1 or 0. For this purpose we can use the modular function in MATLAB. Let me show you. For the first bit plane, and now for the remaining ones. So as you know, for the rightmost bit, if the intensity value is even, then the mode will be 0, and if it is odd, then the mode will be 1. So the first bit or least significant bit can be easily found by this formula. Now let me display them. So as you can see, the C0 is completely random array, and let me display the other ones. Now you can see a small part of the image. C4, 5, 6, and here it is exactly the same as the binary image that we produced by threshold 128.